All right, so the idea is take back your data. It's interesting how this subject is coming up more and more. I think people are, there's a bit of a mainstream sort of discovery of the problem that we think we can solve, of what it means to take back your data. So basically, people are familiar with Facebook. I did I asked a question at CoinGeek. It was funny. So I asked you guys the same question. I'll tell you what happened at CoinGeek. The question is, how many people think that Facebook does a good job of protecting your privacy? Please raise your hand. I see no one raise their hand. And then, how many people think they do not do a good job of protecting your privacy? And everybody raises their hand. So that's exactly what happened at CoinGeek with a larger audience was, literally no one raised their hand and said that Facebook protects their privacy, and everybody raised their hand and said that they do not. Okay, so let's play this thing here. Oh, no, we don't have sound up there. I think that's okay here. I'll put my... Oh, it is playing. Okay. Yeah.
Online are private messaging in small groups and in stories. This is the next chapter.
Okay, so the point of this video is simply that even Facebook is saying the future is private, so they seem to at least be saying the right things, but they haven't quite done this yet. So the problem with Facebook, what is it? Well, Facebook effectively owns your data. Everybody uploads their personal information to Facebook, and what effectively happens is they use this information from Facebook to deliver targeted ads to you. That's the business model of Facebook. In this image, we have here an example of sort of a social network. This is Facebook as you're connecting to people. We want people to be connected peer-to-peer. Everybody's going through Facebook, though. So we of course we use Facebook as an example because if you measure these things, Facebook is the largest social network. Facebook is not the only company that acts the way that they act. Google is also extremely large. It's really Google and Facebook together that basically do the same thing. Together, the two of them dominate online advertising, and what all of them do is to track you and to get as much information as they can about you so that they can create a platform for advertisers to advertise to you based on the information they have about you. They don't really sell your data. What they do is sell the ability to advertisers to deliver targeted ads to you. So these are huge. They're two of the largest companies. And they've sort of taken over, newspapers and things like this. Like newspapers do not do as a good of job with ads because they don't have the data the way that Facebook and Google do. So this is just advertising revenue. All this is showing that the amount of revenue that they're earning from this stuff is really enormous. And there's a reason why Facebook is a huge company.
Thank you very much, Mr. Chairman. Mr. Zuckerberg, would you be comfortable sharing with us the name of the hotel you stayed in last night? If you've messaged anybody this week, would you share with us the names of the people you've messaged?
Senator, no, I would probably not choose to do that publicly here.
I think that might be what this is all about.
Okay, so this is when Facebook was forced to defend themselves in front of U.S. Congress because there was this deal with this company called Cambridge Analytica where basically what this other company did was to take sort of abuse the privileged access they had to Facebook information and use this to deliver political propaganda to people. And we've got another interesting video of this guy here.
Trying to use data and technology to make to allow campaigns to engage with voters in a more informed and relevant way.
Well, we do a lot more than that. I mean, deep digging is interesting, but equally effective can be just to go and speak to the incumbents and to offer them a deal that's too good to be true and make sure that that's video recorded. These sorts of tactics are very effective. Instantly having video evidence of corruption, putting it on the internet.
Okay, so this, after abusing this privileged access to information and making a big deal about it and all this stuff, this company is now shut down. I don't think anybody went to prison or anything like that, but it shows there's at least an awareness publicly of these sort of issues, the way people are using this information, and this is just sort of the most extreme example of violating this idea of privileged access to people's personal information. Okay, so right here is a photo of some of the original members of DigiCash. So DigiCash was a digital currency from the 1990s that you may not have heard of because people in the crypto world today don't necessarily trace their history back to early on in the 80s and the 90s, but DigiCash was an actual existing cryptocurrency that was quite different than Bitcoin and stuff like that. But it's founded by a guy named David Shum in the 1980s. I think it's very interesting to just compare the timeline of these things because it's somewhat instructive about why the internet ended up this way. So DigiCash launched in '89. The web browser was launched in '91. So the people had this idea of digital currency before even the web browser was launched. DigiCash declared bankruptcy. If you listen to Craig has an explanation for this, which is that they were too anonymous, that the banks ended up not being able to work with them. It's really hard to actually research this to know why they really went bankrupt. There's a bunch of information about missed business deals and stuff like that. But in any case, DigiCash did not ultimately work out, and they did go bankrupt, although the brand has now been purchased and owned by some other people. Facebook launched in 2004. So the point of this timeline is to point out that actually there was no digital currency in 2004, was there? There was no such thing. Facebook launched when Mark Zuckerberg just coded up the first version of Facebook, would let Harvard students post their profiles to a website and give all of their information to Facebook on day one. And so they ended up using ads right away. They had one of their original founders was somebody that sold ads for Facebook. So digital currency didn't exist. I mean, it wasn't a realistic option. And Bitcoin launched in 2009. So then it's instructive to just consider for a minute what the future might look like. Facebook is launching Libra. Actually, things changed since I even made this slide, or since Elhe helped me make the slide, which is that, well, the world governments, particularly the U.S. government, has become increasingly sort of opposed to Libra. And some of the backers of Libra have actually already backed out because they've received such blowback from. How many people know what Libra is before I feel like I'm talking to? I'm assuming people know what it is. So Libra is there. Okay, so most people know what it is. It's the cryptocurrency that Facebook is going to be theoretically launching early next year. So anyway, the point is that there is some type of movement towards this. I mean, Facebook, if nothing else, recognizes something's going on that maybe they need to change. I'm hopeful that they do. I'm not really anti-Facebook. I consider Facebook a prospective customer, and if we can help them change, that's what we want to do. We don't want to take down Facebook. It's better that Facebook actually changes and becomes better. Now, history of business teaches us that doesn't always happen. Who knows what's really going to happen? But in any case, I don't regard them as being an enemy, but I do think that we can do things better, and so they're really a customer. Okay, so how can Bitcoin help? I mean, what does Bitcoin have anything to do with this data privacy problem and this type of thing? Okay, so we have a number of properties of Bitcoin that help with this. So first of all, obviously, Bitcoin is money. So we can do things like micropayments. So basically, you can just start monetizing things differently. You don't have to use ads for everything on the internet. You can start charging money for stuff. We have instant payments, borderless payments, compliant. It is easy, although there's all this sort of criminality and anarchism and stuff like this in the crypto world. But actually, you can comply. It's actually using the original protocol. It's actually straightforward to comply because if you look at things like AML requirements and stuff like this, you can comply. We can do it's digital cash, so you can do things like small value payments and all this stuff. Of course, we can do very advanced things, which I only lightly cover here, but smart contracts, pay multiple people at the same time. People do this with MoneyButton all the time, and this is difficult to do with PayPal, but it's trivial to do with MoneyButton. It's to pay 5 different people at the same time. Multi-sig, pay taxes automatically. I'm just putting that there as an example of, well, you can really fit this into the real world, and payment channels is sort of the end of trying to talk about more advanced things, but you can do a lot more advanced stuff than this. What it's not is high fraud and high cost. So we eliminate problems that people have with the traditional payment system. So from a payment system perspective, Bitcoin has a lot of desirable properties. And for people who have used MoneyButton, I think it's fair to say that once you've been onboarded, the user experience is actually better than traditional payments, that the user experience is basically as good as it gets. But Bitcoin is not actually just about money. And this is where, this is undeservedly controversial, but you can store data on the blockchain, and you can do a lot of stuff with data if you uncap the block size and allow the block size to be enormous. So we have wonderful properties with data on the blockchain. So the data is immutable. The data can be authenticated. That is to say, know who created data. It's fast. I like to compare it to a CDN. We could talk about this if people want to talk about technical things, but I believe you can replace the entire internet ultimately with this. It's like replacing the internet with something that's efficient by design because it is a giant CDN where everything can be local and authenticated everywhere, globally. So it would just be like a better internet that's actually more efficient at storing and delivering data globally. It'll be cheap because of the way that it's an economic system, not first and foremost a computer science system. People can create infrastructure businesses and solve all these problems. It will be cheaper because it's so well designed. It will be ubiquitous and redundant, and I mean this in the sense of things like the infrastructure. It already is global, even at a small scale. Redundant basically means things like allowing the economics to govern how many times a piece of data is replicated. Again, I'm not describing a lot of technical details, but I'm making real claims here, and I could explain how all these things are genuinely true. Again, what it's not is high fraud and high cost. High fraud in the sense of fake information. High cost in the sense of basically being scammed by misinformation on websites and stuff like this, which again I could talk about in detail, which I have strong opinions about these things. But basically, authentic information, if you know who created something, when they created it, who is the first creator and stuff like this, which you can know with software, are really remarkable properties. Okay, so a way to look at this is Bitcoin is both money and information. So we're going to use both of these properties to actually solve this problem of allowing users to own their data and creating a system, ultimately, that allows us to replace, or let's say help Facebook, build something that's better where the users own their data first and foremost, and Facebook doesn't have to have a business model that assumes that they have everybody's data. Okay, so here's a sort of caricature of the history of payments in the world. So we have this sort of pre-internet era where people just paid money for information. So you would buy a book or buy a newspaper or something like that. Roughly speaking, it's more subtle and complicated than that. And then roughly speaking, the way it works right now is you get information for free, but that's because you're giving all of your information to Facebook either as a consumer or as a publisher. And then you rely on things like attention. You effectively get paid in attention on platforms like Facebook, and instead of in money. And you pay in your information so that you can receive targeted ads. So these sort of pointless middlemen in the middle of this transaction. The idea is actually return to the basic idea of people just purchasing information. This is a very simplistic way of looking at it. And of course, it's not like Facebook is the only company or something that does this. Traditional media companies use ads. Also, I don't think there's anything intrinsically wrong with ads. The point is not that there's something wrong with ads, more like there's something wrong with the idea that that's the only way information is funded predominantly on the internet. Like there's some type of extreme limit that we've reached where these companies, Google and Facebook, have billions of users, and such a vast quantity of information that people consume is all funded this way. So that's more the point that we've reached some type of like peak of this sort of privacy violating ad-funded information market that we seem to be living in right now. And we want to go back to something better, but where it's on the internet and not necessarily in the real world. You don't have to go to a physical bookstore. The idea would be you swipe money button to buy a book. Okay? And just to give an example of this, just try searching for stuff on Google and think about it when you search on Google. Even Google's gotten worse with their search results. I've noticed a lot of search results are clickbait. You'll see the first 10 results are actually all clickbait. It's very interesting because I can then go do further research. I do a bunch of my own research to try and find real information, and I can find things like actual books on the subject that I'm searching for on Google. How come Google doesn't give me the books in the search results? How come it doesn't show a book that's on the thing that I'm searching for with a money button that lets me swipe to buy it right then and there? They show me clickbait. So I really think we're in some type of like extreme limit where like even Google, everybody thinks Google's very good. I think Google's gotten worse. I think the internet is so gamed right now, even Google has gotten worse, and they don't fully appreciate how serious it is, that they've actually declined. Okay, so what is MoneyButton? So MoneyButton is the world's simplest payment system. And I'm not going to talk about it in too much detail, but you get the idea by watching this short animation. This is basically what we're showing here is the end user facing side of things. We're trying to make it as easy as possible and as friendly as possible to make payments on the internet. Fees are zero, payments are instant. It's the idea is to make it so that anyone can actually use this technology, and the experience is better when you're onboarded than traditional payments. So we have properties like, well, it's easy to pay. That's a consumer perspective, but also we care about the developer too. We want to make sure that businesses and developers that use this have a good experience too. So it's easy to install and it's easy to use this. We also have many advanced features. In fact, I didn't even list everything on here because we're literally launching features as we speak here, but sort of talk about these things. But we do multiple outputs, so you can pay multiple different people with a single swipe. You can do contracts, like we support scripts in the outputs. Data, you can write data to the blockchain. Many of the applications that use MoneyButton both write data to the blockchain and use it for payments. So Twetch, City on Chain, actually most of the apps right now that are pretty popular using MoneyButton, they all do both of them. They all have merged writing data with earning money for the data that you write to the blockchain. There's an OAuth API. So basically what this means is we're making it so that you don't have to have a username and password everywhere. MoneyButton can be your single sign-on identity. And we have built-in currency conversion. So people can see currencies in their local currency that they're familiar with. So I use US dollars. If you live in a different country, you can use whatever currency you prefer and see prices denominated in that. If you've ever traveled to a different country and you notice that you see a bunch of prices in a currency that you're not familiar with, wouldn't it be nice if you always saw prices in a currency that you're familiar with? That's the idea of MoneyButton. Okay, so what is PayMail? So PayMail is human-readable, queryable names for Bitcoin. The basic idea is something like email, but that also supports Bitcoin. So we have this problem in Bitcoin. This is a problem for a lot of reasons. There's a user experience problem whereby, well, gosh, if you ever see something like this, show this to a normal person. This is just, what is this? The fact that people ever have to copy and paste these Bitcoin addresses is just is sort of a user hostile thing. There are a lot of other reasons, but let's just not go into it, and let's just say that we can all acknowledge there's something wrong with this photo here. You have to look at stuff like this when you're using Bitcoin as a problem. The idea is to replace that with something that's friendly to people. So something that's a name. We needed a way to create a naming system that humans can understand, but that also has technical properties that we need to be queryable by machines. Well, email fits the bill. It's the perfect naming solution as far as we're concerned. So it has exactly what we're looking for. People can easily remember their own email address, easily type it in, usually with no errors, or at least minimal errors. And it's also machine queryable. So it just uses standard internet technologies that exist and are ubiquitous, and everyone's already using them for everything already. So people are already using their email address as an identity system. So if it has the properties we need, this is exactly what we ought to be using. So PayMail is just email plus Bitcoin. Now, no one has yet literally implemented both protocols, but the point is they're compatible. You could have, and I could go into this in a lot of detail again if people happen to be curious, but I'm going to skip over the details. But you could implement both of them, but you can extend it to support cryptography. That's a different way of looking at it. But in any case, you can bring this naming system to Bitcoin and just start being able to use this for everything related to identity. And so I'm going to cover some of the stuff here, but I assure you, I've thought about this quite a lot. I'm pretty sure we can solve every single identity-related problem by extending PayMail. It doesn't mean we've solved everything now. It means with straightforward extensions to PayMail and creating new businesses, we will solve everything. And so your email address, if we can convince Google to adopt this, will become your identity. Like it already is. Again, you're signing into stuff, but the point is, it'll just be where your money is. It'll be how you log into your bank. It'll be how you cross the border and stuff like this. Everything related to identity will use this because it has all the properties that we need. So a different way of looking at it, email is, well, effectively it's email that we're all familiar with, and identity because people log into stuff with their email address already. Well, with PayMail, we bring a bunch of other stuff to email. We're bringing payments, signatures, encryption, contracts, extensibility, and so on. We're basically making email much more powerful. A lot of people don't like email, but they use it anyway, so who cares? All right, so today, it's a little bit out of date. This was as of the CoinGeek conference, as of last week. Well, actually, we did launch more stuff yesterday. But in any case, so we're talking about peer-to-peer transactions, signatures, encryption, avatar. So let me talk about what all these things are. So PayMail payment. So the idea is we want to be able to deliver transactions peer-to-peer. The title of the Bitcoin white paper, I think I have it here, a peer-to-peer electronic cash system. What this refers to, this is the title of the white paper. This is the original white paper, Satoshi Nakamoto, in the title, a peer-to-peer electronic cash system. What this means is literally peer-to-peer, as in hand over the digital cash to other people, electronic cash. So you give them a file, which is a transaction. That's the idea of peer-to-peer. It's not about running a node. That's not what it means. So here's one way of looking at it. Here we have an example of the way that wallets tend to work right now. When Alice wants to pay Bob, instead of Alice giving money to Bob, Alice gives money to the miners, and then Bob has to look at all of the transactions in the world to find the one that's going to Bob. This is a silly way to do it. The way that we should be doing it is, if Alice wants to pay Bob, Alice should give the transaction to Bob, because that's what you do in the real world. If you pay somebody, you wouldn't throw it out the window and wait for other people to accumulate all the money and then show it to the recipient and have them find their money back again, because that's effectively how all the Bitcoin wallets are working right now. We're going to go to a model that's exactly like actual cash, which is where you give them a file. Okay, so I'm going to start talking about all the features now. So the first one that we're launching is PayMail signatures that we've launched. This is all live and all this stuff. So PayMail signatures, the idea of this is to be able to sign content that you publish to the blockchain so that people know who created it. So, Chris at moneybutton.com, I don't know what PayMail is, if it's, I don't know, but the idea would be that you can author something and people know who it is because it's signed with your PayMail. So we can attach like a human readable name to digital signatures to content on the blockchain. Okay? So rather than having a public key, and I'm not going into all the details here because it would take forever, but if you ever have to see a public key, something is wrong. You're never going to share a public key with someone. If it's 64 characters or something silly like this, I mean, it's never going to happen. So you're going to share your name with people because they can actually understand what that is. Okay, so, all right, so you can sign with PayMail. It can be on-chain or off-chain. It is compatible with something called the Author Identity Protocol, which is some other protocols people have been creating. The idea here is to be able to sign with a swipe, which I'll show you guys shortly. And we can extend this in the sense of, like, when we say signatures, we're talking cryptography, but we're also talking every meaning of the word signature. The idea will be you'll swipe money button to actually sign something for real, like as in a legal contract and things like this too. So we can leverage this technology while at the same time doing things like, imagine we integrate money button into DocuSign. We're not working with DocuSign. I'm saying this hypothetically. If they like this idea, what we would do is make sure that the DocuSign flow is already there. You would basically want to add a cryptographic on-chain signature to DocuSign by just swiping that you agree after you fill out all the stuff inside the form or whatever that you sign. That's the idea that we're talking about. So we're talking about signatures for everything, publishing stuff to the blockchain. Okay, so the next thing is encrypting data on-chain. So we want the ability to do things like, well, when you save a file, say you go to Google Docs. Now, when you save your file in Google, actually, let's use Facebook example because we were talking about Facebook earlier. Let's say you go to Facebook and you upload a photo, because what you're doing is you're taking photos. Instead of uploading the photo to Facebook, and Facebook has all of your data unencrypted, the way it should work is, well, it should be encrypted by default and uploaded to the blockchain. Because if you do it that way, you properly own your data. You have an encrypted file that only you can access. You can choose to share it, because what you could then do is share the key with your friends, and then they can decrypt it. And if it's on the blockchain, then you're not in some particular company's hands. There are a lot of companies that you're using, but it's not like there's a company that owns your data, whose entire business model is to like read it so that they can figure out how to get ads to you, right? Now, you could still choose to do that if you wanted to. Maybe there's another button somewhere, and Facebook's like, hey, do you want to sell us your content and start receiving ads? We'll buy your content for such and such amount of money, and then you're going to start seeing ads. Some people would agree to that. But the point is to switch to this model where it's encrypted by default. So anyway, this is the type of thing we're doing with encryption. So the idea with this is we're making it possible to encrypt data to a PayMail. This can be yourself. It can be by default, you're saving your photo to Facebook, or you're editing a Google Doc. Or it can be to other people. You type in their PayMail. It's a human readable name you can easily have, or you have a contact list, and you have your contacts, they're already there. Also can be encrypted on chain and stuff like this. And you can share this data with exactly who it is that you want to share this data with. Okay, so these are foundational elements of an own your data paradigm. Again, this is another thing where I'm tempted to go on and talk about this I could talk just about this particular thing for hours. But if you think through how to solve all these problems, these are just the foundational pieces. You need names, and you need signatures and encryption, and you need user friendliness. These are the basic pieces that we've now built into MoneyButton. It doesn't solve everything. There is a lot of apps that people have to create. But based on top of these things, you can now do things like make a Google Docs app, where you can create a file that's encrypted by default and saved to the blockchain, and then share it with people, and then let them edit the document in a way that there is no trusted third party that can also access the same data. And then you could just start charging money for things. So wouldn't it be interesting if you're collaborating on a document with people? Like, let's say you're publishing, well, let's just say it's a for-pay article. You write a draft of the paper, you save it to the blockchain encrypted, you share it with your friends, you send it to their PayMail, decrypt it, they get access to this document. You then share the first part of it for free publicly, put the rest of it behind a paywall. These are the types of things, and then broadcast it to everyone's personal social network so that all the people can see the thing that you published. That's just an overview. That's a very basic idea. If you understand what I just said, well, that actually doesn't even currently exist quite. We're quite almost there. But that's the type of thing that would completely replace the way that people are doing information on the internet right now. It would let you just easily monetize the stuff that you're doing by selling pieces of information and sharing it with these other people and collaborating to do all this stuff. The way the apps will work is they're going to build the tooling around this, and they'll take a percentage, just like a normal company would. Or they'll just charge you a fixed fee or something like this for downloading the app or whatever it is. So you'll still pay money for this stuff. But it opens up these new ways of doing things that are very, very difficult to do any other way without using Bitcoin. Okay, so finally, we have one cool final feature here, which is PayMail avatars. So this is, again, I'm going to use Google as an example here because Google does exactly this. When you edit a Google Doc or you send somebody an email from Gmail, you see their name and their photo. But it's all proprietary Google technology. The idea here is we've extended PayMail to do the same thing, but that's not proprietary Google. It is, anybody can do this. You can run it like an avatar host basically and use this protocol. And you could do things like we like Handcache. We talk to these guys a lot. So wouldn't it be cool if you can edit a document, you log into the new version of Google Docs, which is actually an on-blockchain app. You log in, you author the document, you see your own name and face, and you share it with somebody at Handcache. It's a completely different wallet. But because all this stuff is a protocol, it's not proprietary money button technology, your Handcache user can also log in, and you see their name and face using this protocol. Okay, so if that's clear to everyone. It is decentralized in the way that you would expect, in the way that you would want, which is we're bringing like user friendliness to these basic features that people are used to and using these highly proprietary and centralized applications like Google. Okay, so in conclusion, we're making Bitcoin accessible to everyone. We have this sort of legacy internet world that we're in right now where these major companies are predominantly funded by, they take in your data, you earn nothing by giving this to them, and you have to look at ads that are basically misleading you. And we're talking about creating a new world based on Bitcoin where we have things like privacy by default, and you own your data, and you choose to share stuff, and if you look at ads, it's because you decided to, and you decided to sell your data for money to some company that then delivers targeted ads to you, okay? And what we're doing with Money Button is building all this stuff in the most user-friendly package, both for end users and for developers, to make all this stuff possible. We're not building the apps themselves. What we're doing is making the technology possible for other people to build the apps, at least in theory. And we've got some apps, but we're trying to make it, and I like to talk about the example applications a lot so that people see the potential here to create some of these things. And we're not going to make all the apps ourselves. We just make the button. We're focused on one thing. Okay, that's it for the presentation. Thank you. Okay, so there might be questions, but before we go to questions, let me just show you a demo because we've actually have launched some of this stuff, and I want to show you this demo first because this makes it slightly real. Now, I posted this yesterday, and people joked to us like, this is not for users. This is a developer demo, okay? So if somebody's like, oh, it's not up to Money Button standards, because it's not for end users. It's not an app. This is a demo for developers to point out that all this stuff actually works so they can look at the source code and see how to do it. So I'm just going to encrypt a message to myself. And we were having fun encrypting messages to each other the other day here, but let me post Money Button, Ryan@moneybutton.com. And all I'm going to do is put in some data here. I'll say, my data or something like this. Or I'll say my secret data because it's encrypted. My secret data. My secret data. Now, I'm going to encrypt it on-chain by swiping Money Button. This is how easy it is. So I swipe Money Button. I hope I have internet access. Yes, I do. And I have a transaction ID. So what it did is it encrypted the data with a single swipe and created a transaction. So if you understand the details of that, we're using the same keys that you use to sign a Bitcoin transaction to then also encrypt data. Well, actually, technically, I'm using the key going to my PMail. So anyway, the encryption is done with that key. Well, I won't explain everything, but we are using the keys that you actually use to create the transaction to do this. Okay, now in order to decrypt it, imagine what would go on is you're not going to copy and paste a transaction ID to someone. The transaction will literally just go to them. It'll be an on-chain encrypted message. So they won't have to do this manually, but they'll just receive it. And what they do is they'll say like, oh, you have a new message from such and such person. Swipe to decrypt. My secret data. So because I did this with myself, it seems like a trivial demo. But the point is this is the basics of everything that you actually need to do everything. All this is now built into Money Button. You can sign and encrypt inside of transactions. You can also do stuff off-chain. So this decryption here is actually happening off-chain. I don't normally want to post my decrypted data instantly to the blockchain, if you understand what I'm saying. Say I'm decrypting a message from someone, if you post it to the blockchain, you're making it public. So anyway, the point is that all this stuff works both on-chain and off-chain. So it's up to the app developer to actually build apps that leverage this. But what we've done is to build that crypto into Money Button. So you can use signatures. You can use encryption inside transactions. And you can post things like public keys and PMails and stuff like that in there. So that's a demo, and then I want to show our documentation for all this stuff. So if you visit docs.moneybutton.com, the new stuff is all visible here, crypto operations. We've got videos, which I made between yesterday and today, as well as all this documentation to explain how to do all this. And you've got a bunch of copy and pastable code and stuff like this. So just to briefly browse through here, so these are just examples of the methods that you can call sign, verify, encrypt, decrypt, public key, address, PayMail. So these are like basic crypto things that you can start doing, all related to having a key. And then the developer, again, this is not for end users, this is for developers, will just plug this stuff into their button, basically, And it's actually pretty straightforward. So if you look at the code here, like for the developers in the room, it just looks something like this. So to sign something, you give it a name, and this is like a variable inside your transaction that gets replaced with the data. You sign something, you pass in some content, you give some parameters here, like how it's encoded, which key you're using, and what algorithm, and then you can easily publish like your public key and PayMail and stuff like this as well inside there. So the code is pretty simple to actually use this. Okay, so that was a demo, and I think that that's probably it. So are there any questions or comments for all this stuff?
I'll start. What are you
Yes.
most excited to see built on top of Money Button?
Okay, so I guess the first thing that occurs to me, the first thing that occurs to me is I want encrypted messaging. Like, I mean, this seems like a cool application that we could have on Bitcoin. I think we could solve a lot of problems in the Bitcoin community to start leveraging our own tools to communicate with each other. Which brings me to the next thing, which is actually, I'd really like to see someone build a replacement to Twitter that actually replaces Twitter. So that's a little bit different. Because it's not actually clear to me what all the details would be. But I like social media applications and things like this. I believe we can replace Twitter. And just to back up and explain some context here about for people who may not know me, but the reason why I don't like Twitter is because I built a following on Twitter of 27,000 people over like 8 years. And Twitter degraded into a troll nightmare for me. Because I did things like, well, I was favorable to block size, increasing the block size in 2017, and started being trolled on Twitter. And the level of trolling got really, really ridiculous. And I've recorded videos of this where you can see the insanity. And just to say this, I would say things like, Craig Wright is Satoshi Nakamoto, which is a very needlessly controversial claim to be making on Twitter. And then people would post hundreds of comments of animated poop, I'm not kidding, and just ridiculous stuff. Some combination of real people and bots and just idiots, okay? So anyway, it's like, well, I just can't even use this platform anymore. It's like absolutely disgusting to log in and look at this stuff. But I have 27,000 followers that I lose on Twitter. So this is why I'm so angry at Twitter specifically, because it degraded for me, and it didn't degrade for everyone, but it degraded for me very clearly. It's like, well, this is just a disaster, and I'm screwed, because I just completely lose my following on this platform. So this is why it's not like we created Money Button for this reason. This happened while we're making Money Button, but it makes it really clear why we're making Money Button, which is to make it possible to build replacements for stuff like this. I want to help Google. I want to help Facebook. I even want to help the Chinese government, but I don't want to help Twitter. I want to replace Twitter with something that doesn't suck. Okay. So anyway, that's what I would like to see. I don't have a detailed explanation about what that would look like exactly. So I'll say that encrypted messaging is something that's very clear what that would be. You would just log in with your PayMail, and then type in people's PayMails, and type in a message, and swipe to send, and they would get the message. And that would be on-chain encrypted messaging. That can be a very straightforward application. There's one called PayMail, where they don't quite have this yet, but he's like almost there. I think he might implement this stuff and do it in the full proper way. And people can make other ones. And the interesting thing is there can be more than one of these. Because if you understand everything I'm saying, it's not going to be one app. There can be many different apps that use the same protocol. It's all on-chain. You're not locked into a service provider. All that matters is the protocol for communication is actually widely adopted. So I could send messages from MoneyButton to Handcash to Centbee, etc. Right? So we need messaging protocols and content protocols are actually understood. So it really is on your data. You won't be locked into a service provider. So we need apps to start demoing it, but the apps will be, the idea will be not locked in. So anyway, that's what I would like to say. Okay. In the back there, yes.
Talk about the encryption itself. Is it AES 12? And what about correspondence?
Okay. So let's back up and say something like history of crypto in a nutshell is basically shared secret versus I should say sort of symmetric cryptography versus asymmetric cryptography. So the idea is if I want to encrypt a message to you, people figured out how to do it with like a shared secret a long time ago, where I got to give you like the password to decrypt. And the problem is, well, basically it's really it's hard to do things like have many different passwords. How do you send somebody a message if they don't if you haven't already given them a message in the past that you can rely on? So people figured out eventually in the 70s how to do this in an asymmetric way, where you can actually have a public key, and I can encrypt a message to your public key. Now, what is apparently not commonly known right now is that there are efficient ways to combine all of these different things in something called ECIES. So you can do fast, efficient, asymmetric encryption by combining different things. The way this works is you have an elliptic curve public key. I have an elliptic curve key pair. I have an elliptic curve key pair. We do Diffie-Hellman. I arrive at a shared secret with you. So you publish your public key publicly. we now have a shared secret. I can use a shared secret to do normal symmetric encryption. So this is all encoded in a standard called ECIES. ECIES is basically a high-level description of how to combine all these different things together. There's more than one implementation of ECIES. I created an implementation of this in 2014 that's now in Bitcore. That's widely installed in many Bitcoin wallets today. But we don't use it. There's a different one built into Electrum. So the interesting story here is that think about, like, it's really critical that we all use the same protocol. So we need a very good one that's actually widely deployed. So we're going to use the one inside Electrum. So even though I programmed my own like years ago, we're actually not using that one. We're using Electrum ECIS. It's also called BIE1. It does exactly what I said, but the details are different between its version and my version. So anyway, that's what we're using. That's how you encrypt data. You need someone's public key, and built into PayMail is an identity public key. So if you have a PayMail, your name at yourdomain.com, it's just an email address. I send an encrypted message to you. I query your DNS record. The user doesn't see this, but this is what's going on. I query your DNS record. I find the HTTPS endpoint. I retrieve your public key. We've now attached public keys to emails. So I can now encrypt something to you. This is like PGP, except it actually works for users, right? So I can start doing things like I can send an encrypted message to your email using this technology. Okay, so it's ECIS, and specifically Electrum ECIS is the implementation that we're using for this. And there's in our JavaScript library, somebody copied the Electrum version and put that in our library. So that's what we're using for this stuff.
Is that one changing every time, Brian? The identity public?
So the idea of the identity key is not to change all the time. It will change sometimes. You don't want it to change all of the time because you want to be able to do things like easily verify someone's signature and stuff like this. You don't need it's not for receiving payments, so there's no privacy problem with publishing it. It will change sometimes too, and sometimes though, and this kind of confuses some people. Like, people lose their keys and they get hacked and stuff like this. So the idea is that it's a semi-stable public key that doesn't change all the time, but it does change when you lose your wallet or when you get hacked.
When you're publishing the encrypted message, are you just dumping that inside of OpReturn in a regular Bitcoin transaction, and then you're just telling the recipient, hey, here's the transaction hash, go ask a node, please give me the encrypted.
So let me answer that several different ways.
Okay.
So first of all, the protocol lets you do, like our API lets you do whatever you want to do. The developer can say, I just want the encrypted data back again and not put it on chain. The developer can say, I want to put it in OpReturn. It can say, I want to put it in this place in this OpReturn, or whatever. The developer does whatever they want to do. What my demo does was just dump it in the OpReturn and then print the TXID on the screen. So the simplest way to create encrypted messaging is exactly like that. Like you basically just dump it in the OpReturn. It's just a blob of encrypted data. And then give it to someone, but then give them a hand wave or like an eye wink or something like this. A bit of meta information that says, there's encrypted data in this. Why don't you try to decrypt this and see if it works? Yes?
Your demo, why do you have to pay when you decrypt it?
Okay, so we haven't finished the UI yet. So that's a good question. Somebody else asked that question earlier. So you do not have to pay. It just says less than one. It doesn't say you pay. It says it's less than 1 cent. It's actually 0.
I'd imagine though at some point when we're gonna have when miners start specializing in what they're good at, you're gonna have some that are hashing, some that are just storing data, some that just communicate amongst each other. That at that point we probably will have to pay to retrieve the data because we're not keeping the blockchain to ourselves.
I think that's correct. Yes.
The last part of his question was about encryption post-quantum.
Oh, okay. Okay, encryption post-quantum. Okay, so, all right. So the thing you can do with quantum computers is actually, if you have a public key, you can break this what is it called? Is it the discrete log problem? Am I getting the name? What's the problem called? Somebody give me the name. Yeah, discrete log. So it's like what you can do is you can basically inverse a public key. That's a bit of an issue for some of this stuff, but you can sort of work around a lot of this in different ways. So for instance, don't publish your public key, okay? Or you do something where it's like one-time use public keys, and then don't tell anybody what your public key is that you're actually using in this particular blob of data. And if you imagine how this would work at scale, it would be a lot harder. So being able to inverse one public key, like imagine what you do is you deliver a different public key every single time somebody queried you. And then somebody tried to inverse that public key. But they have no idea if that public key had ever actually been used for anything. So how are they going to decrypt anything? So I think if you did it that way, they would do something like you give them one public key, which they then use to encrypt data to you. So if they are the ones encrypting data to you, then what does it matter if they could decrypt that? So then don't share that public key. So I think you can use a bunch of tactics like this. Like there's basically exactly one thing that quantum computers can do better, which is that, and nothing else. And so they don't break hash functions. They don't break encryption either. It's not that they can simply decrypt your data. They can inverse a public key slowly. So that's it. To the best of my knowledge, I'm not a cryptographer, but that's my understanding of this stuff. So I think that you can use typical techniques to hide information and stuff like this, and just don't let them see the public key that you're always using everywhere for everything, and you probably don't have an issue.
If I can just jump in, I know you have a question. We forget that we can use quantum computing for good too. I mean, you can use it to create more barriers for somebody to hack you. We can use it to mine Bitcoin and make it more secure. So a lot of people just want to attack Bitcoin and say quantum computing is going to destroy it, when they forget they can use it to benefit it as well.
Good philosophy. Yes.
I don't believe that quantum computers like from one day to each other they are going to the next one they are going to have super quantum computer capable to do stuff. Actually, what is happening is that they are developing stronger and stronger quantum computers, and you can see like the evolution. So I'm sure that we are going to develop algorithms to protect us against quantum computer. But it's not that from one day to each other all the public keys are going to be cracked. That's going to happen.
And then I'll also say to that, that's different than the Bitcoin protocol itself, because we can easily change the crypto that we use with PayMail and use something stronger. Bitcoin is a totally different story where it's not so easy to just change the crypto. But Bitcoin, you can do all sorts of things. Like you actually don't share your public keys normally until you spend it. So it's actually quite different.
Can I just to continue on that? I mean, we can also, damn it, that was my train of thought.
Layer public keys.
Yeah, it's about, I forgot it, I'll make it up later. I can't remember.
I was going to say, we put a public key inside a public key. So you give the public key, you give the private key, they decrypt it, and then they get your real public key because your public key was encrypted.
That's a very good idea. Yeah.
You just keep stacking it up.
Yeah. Yeah.
Can I also
Sure.
add something? I think a lot of time people worry about this is because they assume if you have like a public key, right? You have some Bitcoin stored there, and then for the attacker, it's beneficial to attack and get a Bitcoin. But what happens usually is, let's say you have let's say one Bitcoin stored, and let's say I don't know like $1,000, right? So you generally cost you magnitudes larger to attack it. Let's say you will spend like $1 billion, but even now it's more than $1 billion to attack it. And while you are cracking, I can move it like instantly, right? So you can never chase me. You see what I mean? Or even you can, it's not worthwhile. I don't want to use a phrase, but it's risk finance. So it is what it is.
I remember the point now, and it's that I even think that later on there's going to be addresses that never moved, and yes, they will eventually be cracked. I mean, this is as technology improves, but we're also going to increase our encryption as well. So all of the stuff that's been encrypted early on, I think I remember. You think about it. I mean, there might be people that they'll find $1 billion, or not, well, who knows how far out. There could be $1 billion account that it might be worth to do that, and nobody has moved it. But if you're aware of what's going on, I mean, I don't know how you can figure that part out, but you just encrypt it more, and the coins that haven't moved for a while, it would be worthwhile to try to retrieve those, but that's a long way out.
Yeah.
Yeah, I think to add, I haven't fully understood, but if you read Craig's paper, he has one on Bitcoin and quantum computer. But his conclusion is you don't worry about that. It's like, I don't know, it's like a lightning. It's further than 18 months away. It's always 18 months away. It's like a practical quantum computer. Because once you get to a few qubits, for whatever reason, it always breaks down. So that's why you hear all the announcement, but you never see like a working IBM or Google one. But you always hear in the news. It's like a hype. And 2 to the 256 is actually, I think Craig is claiming in our lifetime we don't know about it will never be possible. Because there's a number bigger than the number of atoms in the whole universe. So think about that. Personally, for me, I don't worry about it. Maybe I don't have $1 billion stored in one public key.
Spread your money out. Put it over many addresses, and you don't have to worry about it. Sorry, anybody else have questions? Any questions? Let's go.
I think Joshua had his hand up first. Yes.
How is MoneyButton going to implement P2P transactions?
Okay, well, what we're going to do is, so yeah, we haven't launched this yet, but we have some code written for this. So the thing with the peer-to-peer transactions is something particularly sensitive to everyone actually has to agree, or it does nothing. I mean, we're already doing peer-to-peer transactions internally. The recipient gets the transaction. I mean, like, it's written to our database before, you know. So in order to do the peer-to-peer transaction stuff, we need to be sure we're on the same page with other wallets. So some of this effort is basically just making sure that the protocol is actually something everybody agrees to. So we've reduced the simplicity of it, like we announced BIP 270 and stuff like this. BIP 270 actually has a lot of stuff in it that not everyone actually seems to agree. So we're going to do something really, really simple first, which is a transaction broadcast endpoint first, that we've gotten some people to clearly agree to do it this way. So the way it works is your PayMail, we extend PayMail protocol with a transaction broadcast endpoint. If I'm sending you money, I query your PayMail, and it says, where am I supposed to send the money? And I send it to that endpoint. So that's it. I just post the transaction to a HTTPS REST API that you tell me where that is.
I wanted to ask, what's the best argument for why Craig what's his face, actually is Satoshi?
So I'll tell you my answer to that, because my answer is, so I've known Craig since, well, okay, I've been involved in Bitcoin since 2011, and I watched when Gavin Andresen, John Matonis, and Ian Gregg all simultaneously came out publicly as having validated Craig's keys. Now, before that point, I had heard about who Craig was, but that was the day I took Craig seriously. That was the day I noticed something was slightly off about the Bitcoin Core people, because they immediately revoked Gavin's access to the GitHub repo that day, because they're like, he's probably been hacked, because there's no other reason why someone would say something like this. I'm like, well, of course there is. Maybe he's Satoshi, and that's why he's coming out and saying he's Satoshi, because he's just telling the truth. So I'm like, that's interesting. So I was like a closet, I wouldn't say believer, I would say I was someone that's like, well, I think that he might be, because I know who these people are. I've met Gavin. I know who John is. I've met John too. I'd never met Ian. But the point is like, well, these are people that know about this stuff in detail. They're not going to just say this guy's Satoshi and lie about it or something and be wrong. The three, I mean, maybe one of them could be scammed, but all three. But let me just finish, because the point is, since then, it's not like that's the only evidence. That's when I started taking Craig seriously. Now, since then, well, I met Craig a year later in 2017. It's a long story. But basically, since then, I've done a lot of research on Craig's research, and everything checks out as best I can tell. So I have not seen any signatures, but I'll just say that I'm convinced he's a genius. He's an asshole. Okay, but what does that have to do with anything? It's like everybody's like all on Twitter, they're all angry with him all the time and stuff like that. Like, that actually has nothing to do with whether he's Satoshi or not. Maybe Satoshi's an asshole.
Right.
So.
I'll jump in real quick as well. So I think our society wants to have proof. They want one thing and it's proof. You have to look at the evidence and then make that conclusion on your own. You look for evidence and multiple evidence, then you reach a conclusion. There isn't a single proof that's out there.
Yeah. Bayesian probability theory. You acquire information, you update your probability.
I was just going to say, like, if you see like the genius of someone's argument, in their work that they're writing, and you compare it to the other, compare both arguments, and you see that same genius and that same sort of like really, these sort of mind-expanding, boundary-pushing ideas, and you're like, wow, there's something there that connects. That's a good argument can be made if you see that connection.
Yeah.
Isaac Newton was that way too. Argued with everybody.
Geniuses were never understood. Fair enough.
In no time.
And just to clarify, Craig calls himself a dick.
True. That's true.
He's not the one.
I take it back. He's exactly what it is. Okay, I don't see any more hands, so I guess that's it. I think so.
Cool.
All right, thank you very much.